All right. Well, today, unfortunately, is not Thanksgiving, but we're close. But today we're going to wrap up exponents. So this is our third lesson on exponents. Let me get your attention, please. And we're going to deal with some weird stuff today. So we saved the weird stuff for last. Let me get your attention, please. We talked about what an exponent is. Right now, if I asked you, what does it mean to say x to the fourth, what would you tell me? You don't need to write it down. Just like describe what it means when I say x to the fourth power. What are you doing with x? You're multiplying it by itself how many times? 4 times. That's what an exponent means. It just means multiply it over and over and over again that many times, right? And you guys have an understanding that that's what an exponent means? All right, well, if that's the case, if that just means x times x times x times x, then what would it mean if I told you to do x to the negative fourth? How can you multiply something by itself negative 4 times? That doesn't really make sense, does it? It doesn't. I don't think so either. And here's another weird one. What about x to the 0? What does it mean to multiply x by itself 0 times? That's just weird, right? So there are negative exponents and there are 0 exponents, and our goal today is to understand what those things mean. And we're going to talk about both sort of a theoretical, mathematical way to think of this, and then I'm also going to tell you a story. We'll do story time. And one of them, or both of them, is going to make sense to you. You guys are going to love this. All right, let's talk about our warm-up first. So this was just reviewing what we've already done with exponents. Let me get you answers so you can check. If you're having any trouble with these, make sure that you get some help from me later on. We're going to have a good chunk of time today for you guys to ask questions and to work on your new assignment. Part A, I'm hopeful that you got 8 times x to the 9th times y to the 4th. For part B, let's see, 4 to the 4th is 4 times 4 is 16 times 4 is 62. 256. X to the 12th, y to the 8th. I'm hopeful in part C that you ended up with 5 x's on the top and 3 y's on the bottom. In part D, I hope you reduced 25 over 15, so that was 5 over 3. Ooh, this was interesting. All of the x's canceled here. There's no x's in my final answer. There would be 5 leftover y's on the bottom. So if you missed any of those, just get my help later on. I can help you get that back. Or if you were absent when we talked about when do we add exponents, when do we multiply exponents, and when do we subtract exponents, just get my attention. We can help you out with that. Okay. Any questions about any of those right now? You guys ready to get into the new stuff? Okay, so this is part of our warm-up, and this is going to help us understand what negative exponents mean. So who figured out the pattern? What are we doing each time as we go forward in this table? At first I thought we were adding 2, but that's not consistent here, is it? It's not adding 2. What am I doing to get from a 2 to a 4 and a 4 to an 8? Multiply by 2, right? So if I continue multiplying by 2, what am I going to get here? 8 times 2 is 16 times another 2 is 32. All right. How do I go backwards then? To go forward, I'm multiplying by 2. What's the opposite of multiplying by 2? We're going to divide by 2. Yeah. So let's divide by 2. So take 2 and divide it by 2, and you get 2 divided by 2 is 1. 1 divided by 2 is 1/2. A half divided by 2 is 1/4. A fourth divided by 2 is 1/8. All right, we're actually going to be looking at functions that have tables and graphs like this, but that'll be in the second semester. For right now, I just want to use this to help us understand what negative exponents mean. So, guys, this is really important. I really hope you'll pay attention here. It's also a bit of a challenge and a stretch. So, hey, go ahead and move, please. Eric, right up to that table right there, please. Thank you. Appreciate you. We gave it a shot. We did our best. It's just not working. Please, please, please don't miss this. Pay close attention. I want you to write this down for me, okay? This right here, 2, is 2 to the first power. Agreed? Is 2 to the first equal to 2? What power would I put on a 2 to make it equal to 4? 2 to the 2. 4 is 2 to the 2. Agreed? Ooh, is there a pattern here? What power would I put on a 2 to make it equal to 8? 2 to the third is equal to 8. That's a 3. What power do you suppose I put on a 2 to make it equal to 16? 4. And to make 32, we would do 2 to the 5. Huh, interesting. So then tell me, what is 2 to the 0 power? What is 2 to the 0 power? Look up here. What is 2 to the 0 power? Where would that go? It would go right before this, wouldn't it? Turns out 2 to the 0 power is equal to 1. Isn't that weird? 2 to the 0 power is actually equal to 1. Anybody want to guess what 2 to the negative 1 is? That's a half. And 2 to the negative 2 is a fourth. And 2 to the negative 3 is 1/8. So this is what positive and negative exponents mean. Usually when we have negative exponents, we're going to have some kind of fraction. See how all these were fractions? And actually, did anybody notice that the numbers in these fractions actually match the same numbers that we had here? Did anybody notice that? 2 and 2, 4 and 4, 8 and 8. The next one would be 16 and 16. So we'll talk more about that in a second, but this is where the rules for negative exponents come from. They come from this pattern. It doesn't really make sense to say, take 2 and multiply itself by itself negative 1 times. That doesn't make sense. Like logically, it doesn't make sense. But when we use this pattern, it helps us to understand that 2 to the negative 1 is 1 over 2. So let me give you some more examples here. Down below, you got number 1. It says x to the negative 4th. X to the negative 4th is equal to 1 over, anybody want to take a guess what's going to go on the bottom here? It's going to be x to the 4th. You got it. Nice. Based on that, if you had to guess what x to the negative 10th meant, I'll give you a hint. It's 1 over something. What do you suppose goes on the bottom here? X to the 10th. Oops. X to the 10th. What do you suppose x to the negative 1 is? It's going to be 1 over x to the 1. Ooh, number 4 is tricky. It's got 2 things. I'll give you a hint to get you started. It's going to be a fraction. And there's going to be a 1 on the top. And there's going to be a couple things in the bottom. See if you can figure out what's going to be in the bottom of that fraction. You got it. You guys are picking this up pretty quickly, seems like. All right, now things get really tricky. Are you ready? This is where I really need your attention. You with me? Yes, you guys with me? Okay. This one's also going to be a fraction, but it's not going to have a 1 in the top. What do you think is going to be in the top? X to the power of 4 is actually going to be in the top. You're right. And what do you think is going to be on the bottom? We're going to have y to the 2nd will be in the bottom. So it's kind of like the negative makes it do what? It's kind of like the negative makes it go to the bottom of a fraction, right? Positive exponents stay on the top of the fraction. Negative exponents go on the bottom of the fraction. Okay? Now, I want to look at this last one. This last one's got a really big trick, and I hope you guys will pay attention to this. We're going to move some of these things to the bottom of the fraction, and some of them are going to stay on the top of the fraction, okay? However, be careful because there are 4 things going on here. Not 3, there are 4 things. And all 4 of those things have exponents. Now, one of them doesn't have an exponent that's written right now. It's invisible at the moment. What is the invisible exponent that's on this 5? There's an exponent of 1. And that's a positive 1, agreed? So is that 5 going in the top or the bottom? Because it has a positive exponent, it's going in the top. So I got 5 in the top because it had a positive exponent. How about the x's, top or bottom? Negative exponent goes down in the bottom. My y's, they're in the top because they have a positive exponent. And my z, bottom because it has a negative exponent. So negative exponents often involve fractions. A negative exponent kind of moves down to the bottom of a fraction. You guys ready for story time? All right. Once upon a time, in a magical land of mathematics, there was a family of bases. Bases are the big numbers or letters underneath the exponent, right? There was a family of bases, A and B and C and D, and they all lived together in a big 2-story house. Some of them were happy about what room they lived in, and they had a positive attitude about the room that they were living in. But some of them had a very negative attitude about the room that they were living in. Can you guys spot which ones are happy and which ones are unhappy? C is unhappy. And B is also unhappy, right? So we want everybody to be happy. So we're just going to rearrange the house a little bit. If people aren't happy in the room that they're living in now, we'll just move them to the other story. Okay, so right now, 2 of our family members are happy. Let's leave them where they are. Let's write down the 2 that aren't going anywhere. I'd say A isn't going anywhere. A is happy, right? A has a positive outlook on its living situation. So we'll leave that A there. And there's something downstairs that's happy too. What's happy being downstairs? D is happy being downstairs. So let's leave D where it is. It's happy there. However, we've got this B that's currently living upstairs, and it is like, man, I hate living upstairs, going up and down the stairs all day. This is just the worst place to live. Complaining like crazy. How can we make B happy? Put him downstairs. Hang on a second. Let me finish this up, and then we'll do the what ifs afterwards, okay? Hold that thought, okay? Don't forget it. Write it down if you need to. So B was unhappy. We moved B downstairs. Now B's happy. All right. C was also unhappy where C was. So let's move her upstairs. Now she's happy. So if I looked at this as a math problem instead of as a story about a bunch of letters living in a house, it would look like this. And what I would do is I would just notice like, ooh, this doesn't want to be there. We're going to move that downstairs. And this doesn't want to be there either. We're going to move that upstairs. And then I just write down my answer. A stayed where it was. D stayed where it was. B moved downstairs. And C moved upstairs. And that would be my final answer. All right. You had a what if question just a second ago. D did not switch sides. D stayed in the same spot. Oh, you're okay. So that's a good question. You're talking left and right. Okay, I'm super glad you asked this question. If I focus just on the top of this equation, well, let's focus on the bottom, right? Because that's what you were asking about. If I focus my attention on the bottom here, let me ask you a question. If I rewrote this as b to the 4th and d to the 5th, is that the same thing? Yes or no? If I wrote the bottom that way instead, is that the same thing? Yes or no? I'm hearing some yeses. I'm hearing some nos. You guys tell me what's happening with these two things. Are they being added, subtracted, multiplied, or divided? There's nothing in between, which means no, there'd be a plus in between if they were being added. They're being multiplied, right? Think back to our warm-up on Friday. I know it's been a while, but I asked you a question on Friday. Does it matter what order we multiply things in? And we did a few examples, and we came to the conclusion that it does not matter what order you multiply things in. If you do 2 times 3, you're going to get the same answer if you switch it and do 3 times 2. Either way, it's 6, right? So you were asking a second, very good question. Is D going to be unhappy because it's not in the same spot that it was? It can be in any place it wants to be, right? As long as it's on the right floor, we can move it around. Does that answer your question? Excellent question. Thank you. Yeah. So if I start switching stuff around on the bottom or on the top, like I could switch these two things around on the top, that's okay. The order does not matter. We just got to make sure everything's in the right spot, top and bottom. Awesome question. Thank you for that. Does anybody else have any questions? Can I get you guys to try the second one if you haven't already? Now keep in mind this 3 is a family member in this house. Okay, it looks a little bit different, but it is part of the family. And it does have its own exponent. If it helps you to, go ahead and write the exponent onto that 3. What is the invisible exponent on that 3? 1. So 1. Based on that, is the 3 happy where it is? Yeah. It's got a positive exponent, so it's happy. It's staying where it is. See if you can figure out where everybody else goes. Okay, so I'm thinking about these. All of these things are like people in a house. Some of them are happy where they are. They have a positive exponent. And some of them are unhappy where they are. They have a negative exponent. So anybody that's happy, we want to keep them where they are. This y is happy being upstairs. So I'm gonna keep that y upstairs. This z is happy being downstairs, right? Because it's got a positive exponent. So we'll keep that z where it is. Now the x was not happy upstairs, but we can make it happy. We just move it downstairs. And what's going to happen to that too? It's not going to be a negative anymore because it's not negative attitude. Now it's got a positive attitude because it's in its happy spot. Same thing with this w. Not happy downstairs, but that's okay. We can fix that. We'll just move it upstairs. And once it's up there, then that exponent turns positive. Is that what you guys ended up getting? Did some of you have your letters in a different order than me? Yep. But did you have your y and w on the top and your z and x on the bottom? Then that's totally fine. It does not matter what order we put them in. Now, a lot of times people, are going to put them in alphabetical order. Just to kind of keep things organized, but they don't have to be. All right, flip over on the back. Same idea here. I would like you guys to do 7, 8, and 9, and then please stop. Do we please do 7, 8, and 9 on your own and then stop? I want to go over 10, 11, and 12 with you. Guys, we're getting really close to finishing our notes today. Thank you for your attention. You got this. You got this. Just do those first 3. So several of you had the same question on number 8. Everything went downstairs. There's nobody living upstairs anymore, but what do we got to leave up there? Got to have a 1 up there. All right, your letters might be in a different order than mine, but make sure that your letters are on the right side of the fraction bar. Questions on these 3? Okay. Can you give me a specific piece that you don't understand? So don't think about left and right. Left and right's not important because remember, I can flip-flop the order of multiplication. These 2 things on the top are being multiplied. So don't let left and right confuse you. All I need you to see when you look at this is that some of these things, I'm going to circle the 2 that are unhappy, some of these things have negative exponents. The things with negative exponents are going to move to the other side of the fraction. Okay? So this e to the negative 3rd was on the top, now it's on the bottom. And when it moves to the bottom, it becomes happy. It becomes a positive. Same thing, this g to the negative 4 wasn't happy down here, but once we put it up top, it's fine. We don't move stuff that has a positive exponent. Okay? So it's just up and down. Think up and down. And if you wrote your answer in a different order, it's still right. So don't worry about which one's on the side, which one's in the middle, that kind of stuff. All we're thinking about is upstairs or downstairs. Does that help a little bit? Okay, great question. Thank you for that. Any other questions before we move on to 10? 10's got a bit of a trick in it. What are we going to do with this 7? Leave it or put it downstairs? Ooh, that's my favorite wrong answer. We move stuff based on the exponent. This negative 7 has an exponent. What is the exponent on this negative 7? It's not written. There is a 1 on that negative 7. Is that negative 7 happy? Its exponent is positive, so it's going to stay where it is. So we move just based on the exponent. So the negative 7's staying where it is. Let's write down everything else that's going to stay. The x to the 3rd is going to stay because that has a positive exponent. And the y squared is going to stay. Everything else needs to move. This y to the negative 5, because it has a negative exponent, it's going to move to the bottom. Okay, don't worry about whether it's on the left or the right. It doesn't matter as long as it's on the bottom. And when it moves downstairs, it becomes a positive exponent. So I've taken care of that. The only thing I'm missing right now is this z. This z used to live on the first floor. Now we're going to move it upstairs. And once we move it upstairs, it's happy to be there. All right, now that is the great first step. However, we are going to clean this thing up a little bit. What part do you think we can simplify a little bit here? What do you see that can maybe be combined together? Those y's. You got 2 y's downstairs and another 5 y's downstairs. Why don't we just call that 7 y's? So altogether there are 7 y's being multiplied together on the bottom. So let's just put them together. Nothing that we can put together on the top, though. Everything's kind of different there. All right, see what you can do with number 11. 11 and 12, I'd like you to give these 2 a try on your own. 12 is getting kind of messy. We got a lot of stuff going on, don't we? We'll focus on 11 first. If it helps you to make sure that everything's got an exponent, if you see something without an exponent, stick a 1 on it. So when you get to number 12, think about this fraction kind of as its own thing. 15 over 20 simplifies. They're both divisible by 5. That would turn into 3 over 4. So I just simplified that 15 over 20 and I got 3 over 4. Then I'm going to have some F's and G's and H's. So this is kind of complicated, so I'm going to write down all the stuff that's staying first. This F's staying up top. We got a G to the 6 that's staying on the bottom. Those two things are moving downstairs. And these two things are moving upstairs. Can I get your attention up here really quickly on number 12? If you need, I'll give you a moment to copy that down if you need to. We've kind of moved everything around to get rid of all of our negative exponents at this point. Yeah, and when there's a lot of them like this, I'll show you something that some of my students do. As they go through, they'll put a dot above stuff or below it as they use it. So it's kind of like they're checking things off as they go to make sure they don't miss anything. I think that's a pretty smart move sometimes when they get, especially when they get complicated like this. Can you guys tell me what's going to happen with these F's up here? I got 2 F's and another 5 F's. Stick them together and make 7, F to the 7th. How about my G's on the bottom? Same thing? Yeah. 6 and 1. Oh, that's 7 also, right? Now, the H's aren't together on the same side of the house. What happens when we have the H's top and bottom? What did we do last time when we had the same variable on the top and bottom? You guys remember what we did last time? Here we had some X's on the top and the bottom. Do you remember what we did with them? We canceled out until all of them went away on one side, right? So I want you to picture that happening here. I'm not actually going to write out all these H's. But if I started canceling H's, I'm going to cancel all 3 of these up here with 3 down here. How many H's are going to be left over? Be 5 H's left over, and where are they going to be, on the top or bottom? On the bottom. So we'll have H to the 5th on the bottom. All right, you guys are doing awesome. Let's do some notes here. So these are our actual notes. Now that we've kind of got an idea how this works, main thing I need you to know, if I see something like x to the negative a, that's just 1 over x to the a. So if you see something with a negative exponent, you can just write 1 over that thing. Likewise, if I see 1 over something with a negative exponent, I can just move it up to the top. So some examples of this would be like if I had x to the negative 3, that would just be 1 over x to the 3rd. If I had 5 to the negative 1, that would just be 1 over 5 to the 1st. Some examples of these would be like if I had 1 over x to the negative 2, what's that going to be? Negative 2, we'd move it up, it'd become x to the positive 2, and we wouldn't really need a fraction anymore there. Stick with me here, we're almost done. You got this. I'm just going to work through this problem really quickly. We're going to use the house, and then we'll write down our final answer here. So is 6 going anywhere? No. Nope, leave it there. And what else is staying in its spot? This x to the 4th is going to stay also, agreed? Yeah. All right, what's moving? X to the 2nd is going to move down. Y to the 5th is going to move down. Y to the 8th is going to move up. So we're going to have an x to the 2nd down here. We'll have a y to the 5th down here. And we'll end up with a y to the 8th up here. And then we got some x's that we can combine together and some y's that we can cancel. Combining these together is going to give me x to the 6th. Canceling my y's. How many y's are going to be left over after I cancel? 3. 8 minus 5 is 3. Yeah, and my leftover is going to be on the top or the bottom? Top, because we started off with more on the top. So y to the 3. So my final answer would be 6y to the 3rd over x to the 6th. All right, I want to skip down to the bottom of the page, but I'll pause here to see if anybody has any questions. All right, bottom of the page. Oh, you got this. This is the easiest one. We save the easiest and best for last. Anything to the 0 power is
0.
Close. 1. Anything. Let's look at some examples. We don't need to write any more in there. We've got examples right here. What's y to the 0 power? 1. How about 4 to the 0 power? 1. How about 5,280 to the 0 power? What about this big old mess of stuff in this parenthesis all to the 0 power? 1. Awesome. Okay. I would love for you guys to see if you can do these 6 problems down at the bottom. I'll put answers up on the screen here in a moment so you can check. Once those are done, go ahead and move on to your assignment. Okay, I've got answers on the screen for those 6. If you're still working on them, keep going. Don't just copy down my work. And I'll be around to answer questions in just a moment. Thanks for your patience. I'm just double checking and make sure I didn't make any mistakes. Now, I didn't show all my steps here. If I were doing this on a test, I would go a lot slower and show my steps just to make sure I didn't make any mistakes.